All right, today we're going to pull back the curtain on a part of C programming that's super fundamental, but honestly, it's a little misunderstood sometimes. We're talking about the C preprocessor. Think of it as your code's secret assistant, one that works its magic before your code even gets a look from the compiler.
I mean, have you ever really stopped to think about that? You write your code, you hit compile, and poof, out comes a program. But there's this crucial kind of hidden step that happens in between. It's a whole phase that transforms your code first. And that is the preprocessor, your code's secret assistant. It's a completely separate program that runs before the compiler. Its job is to tidy up, swap out some text, and basically get your script ready for the main event. Now, what's really wild is that it doesn't actually understand C syntax at all. It's just following a simple set of instructions, or directives, that you give it.
So let's properly meet this assistant and check out the powerful tools it's got. And trust me, this isn't just some minor detail. It's a totally distinct and vital step in turning your text into a real working program. Okay, let's dive right in with one of the most common jobs for the preprocessor, defining constants using macros. This is all about making your code way cleaner and so much easier to manage down the line.
We've all written code that looks something like this. You see that number? 3.14159, that's what we call a magic number. And it's a problem because if you use it in 10 different places and then later you realize, oh, I need to update its precision, well, you have to go on a scavenger hunt to find and change every single one. That is just asking for bugs. And here's how the preprocessor fixes that for us. We use the hash-define directive to create a macro. We'll call it pi. Now, before compilation even starts, the preprocessor does a simple find and replace. It zips through your code and swaps every single instance of pi with 3.14159. And here's the key part. The compiler never even sees the word pi. It only ever gets the final code with the raw number already plugged in.
Now, macros can do a lot more than just define constants. They can also look and act kind of like functions, but this is where things can get a little dangerous. These function-like macros are incredibly powerful, for sure, but they are absolutely filled with potential traps.
So check this out. Here we've got a macro called square. It takes an argument, x, and its definition is just x times x. Seems like a perfectly harmless, simple way to avoid writing a whole function for a tiny little operation, right? But let's test it. Logically, you'd think, okay, 2 plus 3 is 5, and 5 squared is 25. That's the result we should get, isn't it? So what do you think the preprocessor is actually going to do here?
And, surprise, the answer is 11. Why on earth is it 11? Well, you have to remember, the preprocessor is just doing a dumb text replacement. It literally substitutes x with 2 plus 3, which gives you the expression 2 plus 3 multiplied by 2 plus 3. Because of the standard order of operations, multiplication happens first, so you get 2 plus 6 plus 3, which equals 11. A totally unexpected and wrong result.
The solution, and really this is the golden rule for function-like macros, is to get obsessed with parentheses. You need to wrap every single argument in its own set of parentheses, and then wrap the entire expression in another set. This forces the correct order of operations no matter what you pass into that macro.
Okay, next up is maybe the preprocessor's most powerful feature, conditional compilation. This isn't just about cleaning up code. It's about making one single code base that can adapt to all sorts of different environments. Think about writing code that has to run on Windows, Mac OS, and Linux, or maybe creating a pro version and a light version from the exact same source. This is the tool that makes all of that possible.
And the structure for this is just a simple logic block for the preprocessor. It starts with hash if. You can have an optional hash elif or hash else in there, and it always ends with hash endif. The preprocessor just evaluates the condition, and only the code inside the block that turns out to be true gets passed along to the compiler. Everything else is just gone. It's completely discarded as if you never even wrote it. A classic example is creating a debug mode. You can define a debug macro to be 1, and then wrap all your helpful little print statements inside an if debug block. Then, when you're ready to ship the final version, you just go change that 1 define from a 1 to a 0. The preprocessor then automatically strips out all that debugging code, making your final program smaller and faster, with absolutely zero manual cleanup. This same logic is perfect for including platform-specific code, like using one function for Windows and a totally different one for Linux, all within the same file.
Okay, that was a pretty rapid tour of your code's secret assistant. Let's just boil it all down to the most crucial takeaways you need to remember. At its core, the preprocessor really does two incredibly powerful things. First, it performs literal text substitution, which we use for constants and those tricky function-like macros with #define. And second, it selectively includes or excludes entire chunks of your code using conditional directives like #if and #endif.
If you remember only one single thing from this entire explainer, please make it this: the preprocessor is not the compiler. It is a separate initial step. It manipulates your source code as plain text, and then it hands the modified result over to the compiler, which is what does the heavy lifting of actually creating the machine code.
Understanding that two-step process really unlocks a whole new level of control. So the question isn't just about what the preprocessor does, but what are you going to do with it? How will you use this secret assistant to write C code that's more readable, more efficient, and way more adaptable? Thanks for joining this explainer.